Alright guys, let's get started on lesson 2 of chapter 4. Lesson 2, we have to multiply fractions and whole numbers. Keep in mind the essential question for this lesson is, what does it mean to actually multiply and divide fractions? Alright, there's going to be two goals for this lesson. You're going to multiply a whole number by a fraction, and then you're going to multiply a fraction by a whole number. It may sound like the same thing, but not really. There's some differences here and there. Okay? Alright, our first goal is to multiply a whole number by a fraction. Just a quick reminder, to make a whole number into a fraction, you write a 1 under the whole number. By the way, before I forget to say, when you start working with fractions, always look at the denominator. That's just my little rule. It's something I tend to follow. It's helped me out a lot. Always look at the denominator of the fractions you're working with. It's going to come in handy a lot later on. But anyways, back to the whole number. So let's think of this. If our whole number is 5, I want to change it into a fraction, I write a 1 under it. Think about what this means. It means you're making 5 groups of 1. Right? Part to whole, you're making sets of 1. If you have 5 parts, that means you have, well, 5 parts. So again, think of it this way. There would be 5 wholes. We start with 5, a $5 bill. Think of it this way. Okay? One whole $5 bill. When we put that 1 under it, say, hey, we're going to take the 5 and we're going to change it into dollar bills. How many $5 bills do we have? You're making 5 groups of 1. So here's my $1, $1, $1, $1. It's a group of 1. I have 5 groups of 1. Okay, that's all you're doing. All right, we're going to work on the guts. And again, I just want to show you what you're actually doing, okay? It's not enough to just do the math. You have to understand what you're actually doing. So on page 266, we have letter A. So we're going to do that right now. Pencil, a little bigger than that. Let's see. We have 6 times 2/3. Okay, we start with the whole number first, and we're multiplying it by a fraction. Now, keep this in mind. We're taking a whole number, and we're multiplying it by something less than 1. By definition, a fraction is less than 1, unless it's an improper fraction. But this is proper. The numerator is less than the denominator. Okay, so we're taking 6. We're going to multiply it by something less than 1. So if it was 1, it would be 6. 6 times 1 is a 6. We have 6. But we want something less than 1. So our answer is going to be something less than 1. Okay, keep that in mind. All right, there's 2 ways to do this. You can use an area model and an equation to solve this. Now please, I know some of you know the equation, you're just going to do the math real fast, get it done, boom. But you have to understand why this is working. Okay, this will come in handy when the problems get harder, when the fractions get more difficult. Okay, so we have 6. Okay, I'm going to go ahead and just draw 6 bars. Okay, there's my 6. Now, remember what I said earlier, look at the denominator? Okay, I'm making sets of 3. Okay, so that's telling me for each whole, I'm going to have to cut it up into 3 parts. 1, 2, 3. I'm cutting it up into thirds. All right, look at the denominator. The denominator tells me I'm cutting this up, all the wholes, into thirds. Okay, now I have it into thirds. Great. Now for every 3, according to this, I want 2. Okay, 2 out of 3. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Okay, so keep this in mind. I have 6. You saw me draw that first. And I'm cutting each one of these holes into 2/3. Each hole, I'm cutting it up into thirds, and for every 3, I only want 2. So the hole is 3. 1, 2, 3. I only want 2. Okay, I hope you see where I'm going with this. Keep this in mind. Each hole just got cut into thirds. Okay? You can see that. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. How many thirds do we have? Okay. Now I should be writing these on this side, but since I don't have much of a margin, I'm just going to go with this. All right, now that's a difficult question. Now, are we talking about what we're supposed to have is a whole, right? If we just cut into thirds, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 parts, right? But we only wanted 2 parts out of the 3. So we're not going to say 18. We don't want all the parts. We only want 2 parts out of 3. So that's, again, if you can just bear with me here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And remember with fractions, we're talking about parts to whole. Parts to whole. So we have 12 parts. Hope you can see that. 12 parts, right? Look at 2, 4, 6, 8, 10, 12. 12 parts. And the denominator, we're making sets of 3. Right? Well, if we take all these third size pieces and then put them all together, how many parts do we have? Or how many wholes do we have? Everything settled. Right? What's the answer? 12 parts divided by 3 parts. We have 4. Okay, the answer is 4. So what does this mean? Now, earlier I said, okay, we have a whole number. We're going to multiply it by a fraction. By definition, a fraction is less than 1. So we're saying 6 times 1, or actually less than 1. So we're going to have something less than 6. Our answer is 4. So we were right. Okay? And you just saw that if I took the 6 and cut it up into thirds, 1, 2, 3, 1, 2, 3, 1, 2, 3, we have 18 pieces. But I don't want everything. I only want 2 out of every 3. And I shaded only 2 thirds. And you saw that we only have 12 parts if I do that. Divided by 3 parts in a set, that means we have 4 complete sets, right? And let me just add that. 4 sets. Okay. Why would we do this? Why would we do this? Let's think about this. Let's think of an example here. Let's say I have $6, okay? Now I'm saying, okay, you know what? There's 2 of us, let's just pretend. I get 2 thirds out of it. For every dollar, I get 2 parts out of it. If you can imagine cutting a dollar into 3 parts, it'd be like 33 cents each, but whatever, let's not go there. But, okay, there's $6. I get 2 parts out of every dollar, assuming you cut everything into 3 parts, right? You get 1 part out of 3. If we do this, basically what I'm saying is, at the end, I'm going to get $4, and you're going to get 2. Okay? So, just keep that in mind. We took a whole, we multiplied by a fraction, that says we want something less than this, okay? Now, another way of looking at this might come into the other goal, but for right now, goal number 1, whole number times a fraction, you're saying you want 6 groups of 2 thirds, right? Just keep that in mind. But anyways, let's just keep going. Hopefully it'll make more sense. I just want you to show what's going on, okay? Now the equation part. The equation, you're going to say, that's it. The equation is easy, all right? 6 times 2 thirds. We're going to change the whole number to a fraction. I already showed you earlier. Put a 1 under it. So we're making 6 groups of 1 times 2 thirds. Multiply the numerator times the numerator, gives us 12. Denominator times denominator, which is 3. We have 12, and we're making sets of 3. We have 4 groups, or 4 complete sets. Okay, same answer. Yes, it was much quicker, but you should be able to visualize it as well. Okay? See what's going on? All right. I'm gonna do letter B right now. Look, people, when you take the test, if you don't want to draw area models, that's fine. If you understand this, you do it whatever way feels best for you. But make sure you understand what's going on, okay? Anyways, letter B. We have 9 times a third. Again, we have a whole number times a fraction. The fraction is less than 1 because it's a proper fraction, numerator less than denominator. So we want less than 9, okay? Again, you're kind of dividing here, aren't you, in a sense? Just keep that in mind, kind of dividing. You're taking some whole and you're breaking it up into smaller parts because you want less than what you start out with. Okay? Yes? Maybe, again, money, because all of you understand money. $9. Maybe there's 3 of you. Yes? No, that doesn't make sense. Go with what I said earlier, making sets of 3, right? You divide that dollar into 3 parts, you get 1 part, and the other person gets 2 parts. However you want to do this. But for now, let's just keep going with this. Since we start with a whole number, I'm going to draw the 9. 9 holes. See, right now, I guess it makes more sense when you have a word problem, because right now, this can mean anything. Are you saying you want 9 groups of the third? Right? 1/3 9 times? 1/3, 1/3, 1/3, 1/3, 1/3, 1/3. Or are you saying you have 9 and you're cutting that up into 3 pieces, and then you only want 1 of those 3 pieces? Kind of weird, right? But let's carry on. There's my 9 holes. All right. And for each hole, I only want 1/3 of it. Remember I said look at the denominator? I want sets of 3. Again, I'm cutting it up into thirds. All right. And for every 3, I only want 1. Part to whole, part to whole. Okay, again, look at the denominator. Part to whole. Keep that in mind. How many parts do I have that are actually shaded in? Okay. Don't count everything, because then if I counted everything, it would be 27 parts. Right? Because 3 times 9, 3 9 times, is 27. But I only want what I shaded in. I only want 1 part out of the 3. So 1, 2, 3, I'll even number them. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So I have 9 parts, and I'm making sets of 3. All right? So what do I have if I do that? You should know by now a fraction of the way to show division. 9 divided by 3. 3. Okay? If I were to take all these third-sized pieces, and if I were to bring this one here and this one there, that's 1 full set. This one here, this one there, that's 2 full sets. And I take this one, put it there, I have 3 full sets. Okay? That's what you're doing. You're taking a whole, and you want something less for whatever reason. You want less than what you're starting out with. Again, if we're thinking about money, you're not getting all of it. You're only getting a fraction of it. You're getting a part of it. Okay? And doing this will help you figure out, well, how much do I actually get? If I get 1 part for every 3, 1 part for every 3, 1 part for every 3, that means I only get $3. That means somebody else gets 6, right? If you go logically. But anyways, that's the area model. Let's do the equation. 9 times 1/3. Okay. You go this way. Put a 1 under the whole number. Now I'm making 9 sets of 1, which means you have 9 times 1/3. Numerator times numerator. Denominator times denominator. Same answer. The equation is much faster, but you have to make sure you understand what you're doing. Okay? You can confuse the numbers. You might divide when you have to multiply, or multiply when you have to divide. This comes into play later, but just start now. Realize there is a situation where that might happen. All right. Yeah, you know what? I think I have space to do it here. All right. 4 times 1/8. All right. 4. I'm going to draw my 4. My 4 holes. All right. And I want 1 part out of 8. So that means I have to divide this into eighths. Let's see if I can pull this off. 1, 2, 3. 1, 2, 3. All right, that should be eighths. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, but I don't want the whole thing. Again, look at what we're doing. We have a whole number. We're multiplying it by something less than 1. So I want less than what I'm starting out. Okay, it could be 4 books, 4 cakes, 4 cars. Something that you can cut up into pieces. Okay, in a sense, you are dividing. Okay, you want something less than what you start out with. According to this, if you go by what I just did, I have 4, and I want 8s. Okay. Okay. Now for every 8, I only want 1. 1/8, 1/8, 1/8, 1/8. Okay. Not bad. Not bad at all. Now here's the deal. Keep in mind, part to whole. How many parts did I actually shade in? How many after I shaded in, how many parts do I have? 1, 2, 3, 4. I have 4 parts, but I want sets of 8. Remember, always look at the denominator. That's always going to play later. Let me say that again. I think it came out weird. Always look at the denominator. That's going to come into play later. So making sets of 8. So you should be able to see that this is half. If you were to take all these fourths size pieces and bring them over, try to see if you can make a complete set, right? 1, that one goes there, that one goes there. I have 4 out of 8, which is what you see here, 4 out of 8. But you could also see that if you shade in this whole side, just one part of it, it's half. 1/2. Okay, let's do the equation. 4 times 1/8. 4 over 1, you know why already. Numerator times numerator, denominator times denominator. Simplify. Always simplify when it's possible. Unless the directions say don't do it, do it. Okay. That is goal number 1, my friends. Taking a whole number and multiplying it by a fraction. All right, now we're going to go with goal number 2. I just want to remind you of something. We are multiplying. Yes, they're fractions and whole numbers, but the idea is the same. I want to remind you of the commutative property. Okay? When you're multiplying, the order does not matter. You get the same product. So for example, 3 times 2 gives you 6, just like 2 times 3 gives you 6. So then why? Why does the order matter? It doesn't matter, but why would you change it? What situation would you need to change it? Why not just do 3 times 2 all the time? Why do we have 2 times 3 at all? Why bother with that? Now it depends on the situation. Okay? Now, with goal number 1, we had a whole number times a fraction, right? Real fast, let me just remind you. We had a whole number times a fraction. Something simple, 6 times half. We have some big number, and we have to cut that big number into pieces, because we're going to divide what's left amongst ourselves, whatever reason. Okay? I'm kind of skipping steps here, but it's supposed to be... Again, I can make a word problem out of this. If we have $6, and again, I keep going with money because I think most of you, I think that's something you all like. Well, maybe not all of you, but it's something that most of you can relate with. All right. If I have $6 and I have to cut that dollar into 2 pieces, meaning for every 2 parts of that dollar, I only get 1. I get half, right? 1 out of 2. That means in the end, I get $3, right? And the other person gets $3 too. But I want you to notice something real fast. If I do this, according to the commutative property, the answer should be the same, right? Now, let's go ahead and get started with something real fast. Let's do letter D. All right. With the other example, we have 1/2. I wrote 1/3. Not the same thing. 1/2 times 3. If this was 3 times a half, I would have drawn 3 holes first and then gone from there, right? But here this is telling me, okay, we're going to start with 1/2. So let's understand the idea of 1/2. Here it is, right? I have 1/2. 1 out of 2. But guess what? I want this half 3 times. Right? Now before I go any further, let me just say something. This is less than 1. Half is less than 1. But I want this thing that's less than 1 3 times. Now, it won't pass. The answer will not be bigger than the whole number that you start out with, okay? Because again, you want something less, okay? But here we go. Half 3 times. I mean, why would we do this, right? Maybe we have the pieces first and we're trying to make complete sets. With the other one, let's go back to this. We have the complete set and we want parts. Complete set, we want parts of it. So we can split it up amongst ourselves evenly. Now here, we have the part and we're trying to build that set. Perhaps, yes? Just something to think of. Let's see what happens when we get to the word problems. But anyways, regardless, 1/2 times 3. Okay, fraction, part to whole. Look at the denominator. We're making sets of 2. 2. So we're making sets of 2. How many parts do we have? 1, 2, 3. 3 halves, right? But the better answer, I know it's an improper fraction, but there's nothing improper about it. The only thing that's wrong with it is, by definition, a fraction is supposed to show less than 1. This shows you something more than 1. Kind of defeats the purpose of having a fraction, but it gives you everything you need to know. You're making sets of 2. You have 3 pieces, but it's improper because it kind of goes against the idea of a fraction. It's supposed to be something less than 1. So let's make this into a proper fraction, or what a fraction should look like. Okay, so here's the deal. We're making sets of 2. Yes, sets of 2. 1, 2. They're saying I have 3 pieces. I have 1, 2 pieces. I still have another piece going. There's my 3 pieces out of 2. But if 2 pieces here, that means I have a whole, right? I have 1 whole. And if I have a piece here, that means I have 1 part out of 2. I have 1 and a half. 1 and a half. That's the answer. The proper answer. Okay? 1 and a half. And you can see that too here. I move this here, that's 1 full. And then this I can put over here, or just actually 1 and a half. Same idea. Now with the equation, you'll see it's much faster. Again, going kind of fast. I think by now you get it. 3 times 1 is 3. 2 times 1 is 2. I'm making sets of 2, but I have 3. I have to divide. Again, a fraction shows a division problem. I can make one group of 2 out of 3. I have 1 left over. But since we're doing we're big boys and girls now, we can't do remainder 1. We have 1 full set with 1 left over, and we're making sets of 2. Again, look at the denominator. Okay? Letter E. You love my straight lines? I know you do. They're so awesome. All right. Letter E. 2/5 times 4. Again, we have the fraction first. We have 4 sets of these, I guess. 2/5 4 times. So this may not look nice. You know what? How can we fix this better? What was it Bob Ross would say? It's just a happy little mistake. Okay. 1, 2. This is going to be really big. I'm not really comfortable with this, but you know what? It happened. 2/5. 2 out of 5. And I'm going to do this 4 times. Oof, it's going to take up a lot of space, isn't it? That's That's 2/5 two times. All right, guys, forgive me for doing this. It should be to scale, but just for the sake of time, 1, 2, 3, 4, 5. Again, if you're going to have a fraction, all the pieces should be the same. Think about pizza slices. You want all the pieces to be the same. Okay, slices, that is. All right, so 2/5, 2/5, 2/5, 2/5, 4 times. Four times, okay. Okay, let's keep in mind, again, that famous phrase keeps saying part to whole, part to whole, part to whole. Okay, look at the denominator. We're making sets of 5. We're making sets of 5. Fifths. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, how many parts do I actually have? 1, 2, 3, 4, 5, 6, 7, 8. 8 fifths. Okay? But again, that's really not the correct way to show a fraction. It's called an improper fraction, but it still tells you everything you need to know. I can even draw it based on this. Okay? I'm making sets of 5. 2, 3, 4. And I'll even count this in. 1, 2, 3, 4, 5. But I have 8 pieces, so I keep going. I draw another hole. 1, 2, 3, 4. 6, 7, 8. I shade it in. I shade in this whole thing because I got all of it. I have 5 out of 5. I shade in 3 parts here because that's what I have. 3 fifths. This is just 1 plus 3 fifths. The answer is just 1 and 3 fifths. Okay? Alright, equation time. Kind of skipped a step, but hopefully you know what I'm doing here. I changed the whole number to a fraction by putting a 1 under it. Numerator times numerator. Denominator times denominator. I'm making sets of 5, but I have 8. I'm going to divide. I can make one group of 5 out of 8. I have one full set with 3 parts left over, and I'm making sets of 5. Okay, same answer. And I have one more. Let's see if we can do this a little better. 3/4 times 5. Again, let's make a little prediction. I have something that's less than 1. Okay? It looks like I might be trying to build a set. I'm trying to get a set here. Okay? How many complete sets will I have? It won't be 5 complete sets because I don't have the full thing to begin with. It'll be something less than 5. Okay, 3/4. 3/4. Here's my 3/4. I shade in 3 parts out of 4. I do this 5 times. Now, I apologize again, if you're going to draw fractions, ideally all the parts should be equal. These are not equal. This would not be a good fraction model, but I just want you to understand the idea behind it, okay? I mean, I can take out a ruler and make all the lines straight and perfect, but that'll just take too much time, okay? But you understand the idea. 3 parts out of 4, 3 parts out of 4, 3/4, 3/4, 3/4, 5 times, all right? And then 5. Okay, what's going on? Part to whole. Again, look at the denominator. I'm making sets of what? 4. There's my. How do I know that? Where's my proof? Where's my evidence? The denominator here is 4. I'm making sets of 4, but I don't want all 4. I only want parts. So how many parts did I actually shade? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. 15/4. But you know that's not right. It's like if we start with an incomplete set and we're trying to make full sets, yeah? It's like if you buy baseball cards. Do you guys even know what that is? When you buy I can't even think of it. when you go to those machines where you put in quarters and you get little figures for sets of whatever, and there's 4 in a set, but you only get 3 of them, you try and build a complete set. Okay, anyways, 15/4. I'm making sets of 4. I have 15 pieces. Yes. I could do the drawings, but you can actually see it here. No, why be lazy? Let's just do it. Let's just do it. Come on. Let's not be lazy. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have a full set, set, 3/4. Okay, it's going to be a little sloppy. This is 4 out of 4, 4 out of 4, 4 out of 4. Okay, work with me here. How many full sets do I have? 4 out of 4 means I have a full set. That's 2 full sets, 3 full sets, 3 full sets, and 3/4 of another one. Okay, now let's do the equation. You know that was coming. All right, 3/4 times 5. Put a 1 under the, which will now become a numerator, right? We're making sets of 1. Numerator times numerator. Denominator times denominator. You're making sets of 4, but you have 15. You're going to divide. You're making 3 full sets, and you have 3 pieces left over, but you're making sets of 4. Same answer. Much faster, but make sure you understand why you're doing what you're doing. Make sure it makes sense.